Dielectrics and electric polarization. Dielectrics are insulates which can be used to store electrical energy. This is because when such substances are placed in an external field, their positive and negative charges get displaced in opposite directions and the molecules develop a net dipole moment. This is called polarization of the material, and such materials are called dielectrics. In every atom, there is a positively charged nucleus and there are negatively charged electrons surrounding it. The negative charges form an electron cloud around the positive charge. These two oppositely charged regions have their own centers of charge where the effective charge is located. The center of negative charge is the center of mass of negatively charged electrons, and that of positive charge is the center of mass of positively charged protons in the nucleus. Thus, dielectrics are insulating materials or non-conducting substances which can be polarized through small localized displacement of charges. For example, glass, wax, water, wood, mica, rubber, stone, plastic, etc. Dielectrics can be classified as polar dielectrics and non-polar dielectrics as described below. Polar dielectrics, a molecule in which the center of mass of positive charges, protons, does not coincide with the center of mass of negative charges, electrons, because of the asymmetric shape of the molecules, is called a polar molecule as shown in figure. They have permanent dipole moments. They act as tiny electric dipoles as the charges are separated by a small distance. The dielectrics like HCl, water, alcohol, NH3, etc. are made of polar molecules and are called polar dielectrics. Water molecule has a bent shape with its two OH bonds which are inclined at an angle of about 105 degrees.
It has a very high dipole moment. Figure B and C show the structure of HCl and H2O respectively. Nonpolar dielectrics. A molecule in which the center of mass of the positive charges coincides with the center of mass of the negative charges is called a nonpolar molecule as shown in figure A. These have symmetrical shapes and have zero dipole moment in the normal state. The dielectrics like hydrogen, nitrogen, oxygen, CO2, benzene, methane are made up of nonpolar molecules and are called nonpolar dielectrics. Structures of H2 and CO2 are shown in figure B and C respectively.